All right, mathletes, here we go. So we're going to be looking at 4.2 today. We're putting it together with 4.3. We're going to do a little bit of standard form by hand, and then I'm going to show you a little bit on the calculator. So go ahead and just take a second and copy down that green vocabulary, and then we're going to go over each section at a time here. So looking at these first ones, standard form has our a, b, and c. Those are just my coefficients. It's always going to go x squared, x, and constant. And we like standard form because it gives us the y-intercept. It is always our c value at the end, okay? And when I need to find a vertex, we'll show you guys how to do it on a calculator, but algebraically, we use this formula, negative b divided by 2 times a. Once we've found that, that's our x value. In order to find y, as always, if we have an x, just plug that sucker in and you'll get the y. And that's going to help us get our vertex. Increasing, decreasing, we've done in the last couple units, so we're just looking at the interval of where our x's are saying that the graph is going up and where it's going down. All right, over here we're looking, minimums happen when my a is positive, so I'm opening up, giving us a minimum. And maximums happen when my a is negative, and I open down to give us that maximum value. Axis of symmetry, you should see that exact same formula we talked about with the vertex, because the axis of symmetry is the x value of the vertex. It is also the middle of the parabola. Okay, we'll always cut it right down the middle. Now our end behavior, as we've talked about in the previous units, rising, we're going up at the end, falling, we're going down, and number of zeros. So if my parabola does not touch the x-axis, there are no zeros. If the parabola has the vertex sitting on the x-axis, there's only one. And then if the parabola crosses over the x-axis, there are two. That is the only option. You can't have more than 2 zeros. So let's go ahead and look at this first example. So just to start us off, we are in standard form, and we look at our a, and we go, okay, a is negative, which means we are going to open down, which will then also give us a maximum. So those go together. All right, so when I look at the axis of symmetry, we have to do this equation, negative b divided by 2a. So b is positive 4, so we just switch the sign to negative 4 divided by 2 times a is negative 2. That gets us negative 4 divided by negative 4. Please make sure you multiply the denominators separately. Do not put into your calculator negative 4 divided by 2 times negative 2. All right, that was a do not. And so that gets us that our x value is 1. So there's our axis of symmetry, x equals 1. So that also tells us the x value of the vertex. And we find the y value by going ahead and plugging that 1 in. So I'm going to look at my equation. You guys can kind of see that equation up at the top left corner. Negative 2 times my x value of 1, square it, plus 4 times my x value of 1, minus 5. So I would go ahead and put all that into your calculator, and we will get negative 3 for our y value. So that tells us our vertex. So let's just go ahead and plot 1, negative 3 as our vertex. All right, now I can do my falling and falling because I know that it's opening down, so I already know what that's going to look like. We can skip a couple of these for now. The y-intercept, remember from our definition, always comes from the c value. So since it's in standard form, I can go ahead and pull that my y-intercept is negative 5. Now, number of zeros, all I know at this point is that it's opening down. Well, that's not touching the x-axis, so we're not going to have any zeros. We know that our domain is always negative infinity to infinity. Let's go ahead and plot that y-intercept. All right, and then I can reflect it across my middle line, and we can get a better estimate on what our graph looks like. All right, so our range, bottom to top, so it's starting at negative infinity, and it's going to stop at our y value of the vertex of negative 3. It's not in factored form, so we can just say not applicable there. And increasing, we start increasing from negative infinity to our x value of 1, and then that parabola turns around at 1 and starts to decrease off into infinity. So that's how we would do that by hand. Now I'm going to show you guys some word problems that we're going to do on the calculator. I have attached a little cheat sheet for you guys, so I'm showing you how to do it right now, and then the cheat sheet you can look at if you're getting confused, or you can rewatch this as well. All right, so example 2. I want to use this equation to find the attributes. So the first thing I'm going to do is I'm going to plug that equation in. So I'm going to go into y equals, and I'm going to plug this equation right here. Negative, make sure you're not putting a minus sign, negative 16x squared plus 48x plus 3.5. All right, so I'm going to press enter. And I'm going to graph this and get a general idea of what that looks like. So we're way off. You can see that this graph is all the way up here somewhere. So we can adjust our window is probably one of the easier ways. You can just see we need to go a little higher, which means our y values. So if I just go to my y maximum, and let me just make this go to 20 and let's see where it's at. You guys can mess around with this window a little bit. So all I did was let us go up a little bit higher. We still aren't there, so let's go ahead and go a little bit more even. Let's even jump up to 40, just make sure we get that maximum in there. There we go, perfect. So now we see everything that we need to see. And all I did was I went to window, and you can adjust how high your scale goes, and you can also adjust left and right how far it goes. All right, so the first thing I want is the maximum or minimum. So this is a maximum. We knew that from the negative a. And so here's how we're going to do this. Second trace brings us to all of our calculations. So I can go down to maximum, and then it's going to ask me for a left boundary. Well, my maximum's right here, so that is to the left. So I can just press enter here. And then I'm just going to move this until it's to the right of that maximum. And in your Calculate 84 app that I gave you, once you press enter that second time, it's going to give you the answer. There is no guess, but if you have the actual calculator, you might have to press guess. And it gives us that our maximum here is 1.5 for my x value and 39.5 for my y value. All right, so the next thing I want to look at are my zeros. And let me just make sure that we're all on the same page. If it is a real world problem, our zeros will only be positive. Remember, because we live in the real world. This one is not. We'll look at that later. This one's just saying, hey, tell me what it is on this equation. So we can see that we've got a 0 over here, and we've got a 0 right here. So I'm going to do the same thing. Second trace and 0. So I'm going to go down to 0, press enter. Left bound, right bound still. So I'm going to go ahead and do this 0 on the left. So I'm going to go down to the left until I pass it. There we go, I'm past it. Enter. And now I'm going to go to the right until I pass it on the right. Enter. Guess, yes. All right, so my 0 here is at x equals negative 0.07. And then I have another one, so I get to do that process again. Second trace, down to 0, and I need my left bound, right bound, so I'm just going to get a little closer here. This is on the left of that 0, enter, and I'm going to go pass it on the right, enter, and guess. So my next 0 is at 3.07. Again, you can absolutely use that Calculate 84 app. In my opinion, it is a little easier. All right, so this one says given x equals 5. So if I'm given an x value, I'm going to go ahead and just put it in with trace. What trace does is says, tell me what x you want. And if I put in 5, watch what happens at the bottom. It says, oh, you want to know where x equals 5? Press enter, and I'll tell you. So my y value here is negative 156.5. So it says, all right, when x is 5, here's my y. So that's what trace does. So if I said, well, what if x was 1? And press enter, and it would tell me my y to go along with it. All right, the next problem here says, given y equals 22, I want to find the x. Okay, well, we need to do y equals. We're going to put in a second equation. So I'm going to go to y equals. I'm going to go down to my second y values. I'm just going to say, what if y equals 22? And you're going to see a horizontal line drawn. And I want to know where that is and where that is. Okay? So we're going to go second trace again, intersect, because I want to know where these lines intersect. So we're going to put this into y equals, then we're going to use intersect. All right, first curve, you say yes. Then it jumps to your second curve, you say yes. Guess? Yes. So it tells us the first place it intersects is at 0.45. But we see there's also a second place that it'll do that. So we just go ahead and go second trace again, down to intersect, first curve. So I want to get it a little closer to my other intersection. So it picks that one up and not the same one. Now I'll say, yeah, first curve, second curve, guess. And there's my second intersection. So notice we just had to move it a little bit closer so that our calculator could do its job. It just finds the nearest intersection that you have it by. All right, so that's how we're handling the graphing calculator. Let's do one more example here, example 3. All right, so I'm going to go to y equals, and I'm going to clear this out because we got a new equation. And we'll watch this again. So I'm going to put this equation in here, negative 16x squared. I know it says t. It's all right, it's just a variable. Plus 80x minus 10. All right, so I'm going to graph that, make sure I can see what I need to see. We cannot. It's way high up there. So I'm going to go to my window, and I'm going to give us some vertical space. So let's go up to 100 feet and see how high that takes us. All right, we're there. Okay, I just chose 100 feet at random. You guys can guess and get your own measurements in there and get your own view of your calculator. So this is talking about 4th of July, fireworks are being shot. All right, so we're talking about fireworks here. Now, our x value is always going to be time. So in this case, it's our seconds. Our y value in this case is height. All right, so we'll talk about feet. That G got lost. There we go. All right, so we want to ask, when will the firework reach the height of 75 feet? So what it's telling us is my height, y, so it's saying y is 75 feet. When is that firework going to get there? Any when means x, because it's talking about seconds. So it's essentially saying if y is 75, what's x going to be? So guess what? We got to go in and go y equals 75, and let's figure out where that happens. So there are 2 places that happens, so we want to find where these lines intersect. So second calc, 5 for intersect. Your first time through, you can just say, yep, first curve, second curve, guess, and that intersection happens at 1.53 seconds. And then we'll go ahead and find that second one. So we'll go second trace, intersect, and we just want to make it closer to the other intersection that we want. First curve, second curve, guess. That happens at 3.47 seconds. All right. Question B. How high will the firework be after 3 seconds? Okay, so 3 seconds Remember, seconds is our x, so that means they're telling us that x equals 3. So remember up here where we said x equals 5, so we're going to use our trace function. So we're going to press trace and 3. And it's going to tell us, hey, at 3 seconds, that firework is going to be 86 feet high. We're only looking at the y here. So you say, hey, at 3 seconds, we're 86 feet high. C says, what is the maximum height the firework will reach, and when is it going to get there? So it's asking for my y value and my x value at a maximum. So we're going to go second trace, and we're going to find its maximum. I need a left bound, so I'm going to go pass it on the left. I want to pass my maximum, which is right at the top. So I'm going to pass it on the left, press enter, and now it says right bound, so I'm going to go ahead and pass it on the right and press enter. All right, so my maximum says 2.590. So remember, that means that at 2.5 seconds, that firework is going to be 90 feet high. So you get a maximum, you've got seconds and feet. That is 99% of the time what we're going to talk about in these real world problems, seconds versus height. And lastly, when will that firework reach the ground? So this is what I was talking about, how we're only going to need positive answers, because really that firework is going to start up here somewhere on its cannon. Choo! So if we go find the 0 over here, it's negative. Negative seconds are not real. So we only care about this one in real world. So we're going to go second trace. Remember, we're going to find our positive 0. So I'm going to go to 0 at 2. Left bound, right bound, well, it's here, so I'm already to the left. Sure. And now I just need to pass my 0 on the x-axis on the right. So you would have seen my cursor just drop down below it. And you see your little markers here essentially creating a boundary going, hey, it's somewhere between here and here. Let the calculator do the work. Yes. So my 0 is at 4.87 seconds. That firework is going to reach the ground. All right, guys, I hope this helped. Go ahead and start working on your practice and make sure to let us know if you have any questions.